This ITEC Mini-Lecture is going to be dealing with records. Now, to introduce the concept of records, first we have to think about one case where they may be useful. So let's consider we have an employee database where we have a name and then a particular title and then, say, a salary. And let's continue on. And if you notice, I'm being very careful to make sure that each of the columns are the same length. So the entire point of this is ITEC doesn't really work all that well with variable length input fields. So we're not going to be addressing that particular problem in this mini lecture, but we're going to be looking at just different employee records such as name, salary type, or job title, and salary amount. Now, these pieces of information are linked together. And if we look at what we currently know in terms of ITEC, we could have a variable that allows us to, say, read in the number of employees. This would be a reasonable addition to an input file. And then we would have to have several arrays to hold this. So I'd have to have a type name that is a string of, say, 1 to 3 characters, and then we would have to have a type for the job title, which would be a string of 1, 2, 3, 4, 5, 6, 7 characters, and then we would have to have a particular type for the salary amount. But the reason for those types is well, if we wanted to have our name array, this would be an array of range, natural, of name. So this would give us an array of names. And then we could then go on and then use the T to have an array of titles. And then we would have a salary array except instead of the specific type, we could just say of integer. And then we could read in the particular salary, and then once we have, or not salary, sorry, read in the number of employees, and then we could use a declare block to go through and create a array of these particular types, and then so on and so forth. So we would have to be dealing with parallel arrays, and whenever we wanted to access one particular part of this, we could do this. Now this works, however, it requires programmer discipline to keep all of this information together and realize that it is linked by a particular index, and so on and so forth. And this is a pretty standard problem. And there's a better way to do it than creating essentially arrays of each of these particular types. So these 3 pieces are the link part that are sorry, not these 3, but an integer wouldn't be a num, this would be a salary, and then the name which is a string, and then you have a title, which is also a string. These three pieces are essentially grouped together. And in Ada, we have something called a record that allows us to group all of these together. So I'm going to say this is my employee type that is a record that contains a salary, a name, and a title. And unlike with procedures and functions where you have employee, it's in record. So this is more like a loop. So now instead of having an array of each of these types, I'm going to have my employee array is arranged, and instead of this, I'm going to have it of type employee. So now I can declare this So now we can go through and use a for loop to read in each of the different pieces for this, and to access inside of a record, you simply specify the record and you have a dot specified by the field that you want read in. So in this case, we read in the name first, and then once we've read in the name, then we can read in the title, and then we can read in the salary. And then let's duplicate this and change these puts to put underscore line. And the name and title don't need the IMG, but the salary definitely does. So this will let us know if we successfully read in the particular types. So let's see if we have any compile errors. And obviously we do. And I think, oops. So I have apparently forgotten my array syntax. So pardon me for a second while I go refresh my knowledge of this. Okay, back to the source code. So got a couple of things in the wrong order. And let's see here, I have forgotten an end loop. I just called it regular end. So that means I forgot an end loop in the beginning. And just use the end for the declare block. Get the syntax right. Okay. And what are we complaining about here? Statement expected. Oh, extra semicolon. and then none is not visible, and that is because I accidentally deleted it as I was cleaning up source code. So I'm going to be using file redirection so I don't have to type all of this in. So now we have a particular data error. And one of the ways that we can use to debug this is just natural print statements that let us know where we are at in our particular code. So by adding this statement, we'll be able to figure out if the error is there. And then down here, I can use a just simple put underscore line that says read in name. Title. And salary. So now when we run this, we'll be able to tell what's wrong. So I read in the name, I read in the title, and now it's reading in the salary. So it got a data error. So it's not a constraint error because it's not in the range, it just got the wrong particular type of data. So let's use a look ahead to see exactly what we are currently reading. So there's a problem with the salary, so let's do a look underscore ahead of C::EOL, and then we'll do a put underscore line of C IMG because it's a character and I have to turn it into a string, and this will tell us exactly what our problem is. So I have a T, so let's look at our input.txt and see what we're working with. So I've got a dentist, so perhaps I need an extra character in the title for this to work. And this is probably the case because there's an extra space in the title, or because it included the space when I read it in. So we read it all in, and we got our name Joe, a dentist, and it is spaced off by 1, so that was the particular problem with this. So this is one example where using the look ahead helps us to figure out how to adjust our particular program to deal with this. And the issue was we needed 1 extra space before we could read this in. So now you have an example of how to group information together with records. And records are like arrays because whenever you compare them, you can say record A equals record B, and that will compare each of the different pieces inside of the record against each other. And in other words, it will be a deep comparison. So if you're looking at just making sure to see is record at 1 the same as record 2, it's not going to be checking memory locations like it does in Java when you're looking and comparing 2 different classes. And whenever you're assigning record A to record B, it's going to do a deep assignment. It's not going to do any of the memory manipulations there. So you have to be very careful when you're working with records and realize you're working with just pure data and grouping data, and that data is behaving the same way as every other part of Ada that we have seen so far. So records are a great way to group information together, and they also allow us to make arrays of them, which can then be declared or combined with what we saw with declare blocks earlier. And we saw a little bit of interactive debugging and and how you can go through and add print lines to help you figure out what's going wrong in your code, and then using a look ahead to be able to find a problem in an input stream and correct it. So that's all for this particular mini lecture.